so let's take a look at some of our fancy factoring here. Number 1 is circled. They want me to do that one with you. So the directions, you're just going to factor completely. Do not solve anything, okay? So just ignore the equals 0 part. When I look at number 1, I notice the polynomial does not have any common terms throughout all 4 terms. But the fact that it is 4 terms kind of leads me to what kind of factoring I'm supposed to be doing. Do you guys remember what kind of factoring you use when it's 4 terms? Yes, it's called grouping. Very good. Factor by grouping. So there are 2 groups here that we're going to look at individually. And the first group, x to the third plus 4x squared, what is the common factor between those 2? Yes. And if you take out an x squared, what are you left with? Very nice. And the way factoring by grouping works is whatever you take out of the second group, you want your parenthesis group to match the first one. So what should you take out of the second group to make this work out? If you take out a -4, that'll change your terms. -1 would make more sense, of course, like I said. -1. You said -1. That would change everything positive now, so it's a positive x plus 4. And now that your parentheses totally match, okay. So common factor, take that all the way out of the problem. The x plus 4 comes out. But what else do you have left in this problem, guys? X squared minus 1. Now, Algebra 2 teachers would claim if you're trying to fully factor this, you aren't done. Because x squared minus 1 factors again. This is the difference of 2 perfect squares. So for the sake of practicing your full factoring, could you guys please factor that all the way down to x plus 1 times x minus 1? And then x plus 4 just drops down. So remember from Algebra 2 experience, anytime there's like a follow-up factoring moment, it shows up usually as one of your special patterns. So whether it's the difference of 2 squares or one of the cubic patterns, those are the ones you got to watch out for at the end of the problem. Alrighty, take a look at number 3. There's no common factor on number 3 between each term, and it's just a simple trinomial. So your process is just the reverse foiling process. So we talk about, first terms multiplying together to give you x to the 4th, and that kind of gives kids some pause because they're like, wait, what am I supposed to do? Well, if you look into the middle of the problem, you want your arches to add up to something x squared. So it would make a lot of sense for you to use x squareds. And if you jump to the end of your factoring problem, you want your end of your factors to multiply to -18, while your arches add up to -7. So I'm hearing -9 and +2 would take care of that. And then your Algebra 2 teacher is going to tell you aren't done. Because x squared minus 9 is the difference of 2 squares again. So this factors again into x plus 3 times x minus 3. And then the x squared plus 2 is the sum, which means it won't factor again because the squared pattern for sums, does anybody know how it does factor? We don't talk about it because it's imaginary. You have to use eyes in order to factor that one. For a fun time at another date, maybe I'll show you this, but it's homecoming week. You can't handle this.
Yeah, right. Do we have a
No.
Oh my gosh. Blessing in disguise.
Happy homecoming, everybody. Let's do number 4. All right, 4 is just like number 6, and I think it's the hardest question on the page. So there's no common factor. So you're like, oh, well, it's just a little trinomial. How hard could it be? So apparently pretty hard if the teacher said so. So my lead terms have to multiply to x to the 6th, and I know there's a few ways to break that down, but if you look at the middle of your problem, you want your arches to add up to x to the 3rds. So let's use x to the 3rds. And then everyone freaked out at first because they're like, 125? That's a big number. But look at your middle of your arches. It's got to add up to 124, negative 124. Yeah, and let's make the 125 a negative. That would totally work. And then a lot of kids look at that and go, well, that looks great. Let's move on. No, because it's a cube root. This is a to the 3rd minus b to the 3rd. And this is a to the 3rd plus b to the 3rd. And I would say some of you in here, no offense, I don't know if you have this memorized. Okay, so here's my thinking. I'm pretty bad about memorizing things just for the sake of memorizing them. So if you start thinking about like, okay, how is this formula being developed? It's a little easier to recall it when it comes up later in your math life. So let's talk about this one right here. When you go to factor the difference of 2 cubes, we know it's like a binomial times a trinomial. The trick is, can you figure out what goes in the parentheses? Yeah. So here's how I figure it out. I take the cube roots of the numbers with the same sign, and I write that in the binomial. So that would be x minus 5. When I go to write down the trinomial, the way the trinomial occurs is you square this, so x squared, then you multiply these together, but you give me the opposite sign, so plus 5x, and then the last part of the trinomial is that squared, so plus 25. That's it. Now, the other pattern, this guy, this is the sum of two cubes. It's the same sort of pattern, but your signs are going to be a little different, but the same idea, right? So you take the cube roots of each of them and keep the same sign, so x plus 1. And then we square this, so x squared. And then you multiply these together, but give me the opposite sign, so minus 1x. And then square this, plus 1. Does that kind of help you derive that formula? I think, I almost feel like it's a kinesthetic process at some point. We called it a factoring dance in the last hour, but that was a little much. You can't. That's what I love about this pattern so much. Once you get to the binomial times the trinomial, you can never factor it further. Like, it's not possible without the use of imaginary numbers.
Why not?
I don't know. How would you factor it? Well, you could use quadratic formula. It'll produce imaginary factors. So let's not. And say we did. That is the right answer, right? If you flip over to the back, the keys on the back. It might be in a different order, but something like that. Yeah. And it's way less colorful. I like mine better. It's a little gray looking, huh? All right, let's look at number 7. 7 and 8, very similar to each other. So at first glance, 7 kind of looks like a trinomial. But we're not ready to dive into the reverse FOILing process because number 7 has a common factor. Do you see it? Yes. So you got to start by taking out the x from the problem, leaving it in front of your trinomial, and the resulting trinomial is x to the 4th plus 5x squared minus 6. Now that trinomial, that factors. So leave the x in front, and it's just a little reverse FOILing factoring question where we're going to use x squareds for the lead term, right? Because that would be x to the 4th. It would work out in my arches. I need the ends of your factoring to multiply to negative 6. And then, well, that would be positive 6. I need them to multiply to negative 6 and add up to positive 5. That'll work. And then Algebra 2 teachers, because they're mean like this, are going to say you're not done. Yes, the x squared minus 1 is the difference of two squares, which we always expect you guys to take down further and factor. If the directions say to completely factor, this is what we're talking about. So x drops down, x squared plus 6 does not factor further because the sum of squares is not a thing, unless you want to use eyes. Okay. You have enough information now where you should be able to knock out the rest of that worksheet. There should be some time at the end of today's lesson where maybe you can finish this worksheet up at least. You're going to have, obviously, your homework from yesterday to finish, and then you have a new assignment today as well. We got graphing calculator fun today, guys, so go ahead and get out your graphing calculators. So about a month ago, I had you guys do a lot of what's called linear regression. So when we went to the stat calc menu, you guys chose number 4. But I don't know if you took a tour of that menu. There's a lot of things in that menu. Right under linear regression is quadratic regression, there's cubic regression, there's quartic regression, there's exponential power regression, there's something called logistic growth that we'll talk about in the upcoming lessons in about a month. There's sinusoidal regression that we'll talk about next semester. There's a lot of things, because if you think about real life, very few things in real life actually behave like a line. Most things don't. So that's part of analytics, is to take your real life data and fit it to a mathematical model. And that's what we're going to start to dive into today. So this first question, you're going to just watch me, because I already have all my data entered in my list, because it takes forever to type for me. So this data, for me, it is in list 1 and list 2, which you guys do not have to enter anywhere. But this is on, I think it's worksheet 4. And it's the, we have an oil tanker that collides with another ship, starts leaking oil, and they've plotted the amount of hours that have gone by versus the flow rate of the oil into the ocean. That can't be good. All right, so what I did is I entered the data into list 1 and list 2. So just so you guys can remind me where I go, where did I go to enter data into the list? Do you remember what menu that was? We went to stats, and then you choose edit. So as far as your notes go, you don't have to type anything, but maybe write down some notes to yourself. So to enter your data, you go to stat, edit. I already have the data sitting there in list 1 and list 2, but you guys would have to overtype or clear your list out and type it in for your homework. You don't type it right now, though. The next thing I'm going to have to do, technically, I'll be honest, on a test, I'm just going to tell you what regression to use, but what you're supposed to do is go look at your scatter plot to determine whether you have a line, a quadratic, an exponential, a power. I'm not going to make you do that on a test, but we might make you do that on the homework. So, if I go to second y equals, which is where my stat plot menu is, and I open up plot 1. Number 1, I need to turn it on, which I already had it on. I need to make sure it's graphing for me the right type of graph, so I want a scatter plot. My data was in list 1 and list 2. I don't really care about markings or colors, so whatever. And then do you remember how I make the window automatically adjust for my scatter plot? Remember which zoom I choose? Zoom stats. When it's a stat problem, we use zoom stats. And then I get that picture. So, first of all, do you feel like that's a line? What? How about no? Okay. Do you feel like I could claim that to be a quadratic function? Does it kind of look like a piece of a parabola? I think so. So what they want us to do now is to do quadratic regression. So I'm going to back out of this, go to the home screen. I'm going to go to stat, and this time when I wanted to calculate something, I go over to calc. Oh, but before I do this, the first shortcut I want to show you. We had to turn our diagnostics on before we start doing these questions. And when I originally showed you guys how to turn diagnostics on, you guys had to go to your catalog down here at 0, and you had to kind of scroll down to diagnostics on, and that still works, but that's like the way the older calculators did it. The newer calculators, if you have a newer one in front of you, if you just, everyone go to mode, I never realized this was down here. There's a stat diagnostics button. So just make sure it's turned on when you're doing these. See? There's one shortcut for today. All right. So once you turn them on, you're good until you reset your calculator. Okay, so back where I was. Stat. This time I'm going to go over to calculate. So on your notes, you're going to write down a little note to self. You go to stat, over to calc. And we decided this looked a lot like a quadratic, a parabola that was upside down. And I think it tells you in the problem somewhere like use quadratic regression. So choose number 5. If you were doing this with me, you would choose number 5. And then my data was not in list 5 and list 6. That was from a previous question I did. So I'm going to use list 1 and list 2. If you're using an older calculator, remember if you just keep putting them into list 1 and list 2, it'll default to list 1 and list 2 every time. Otherwise, you just would have to type them. Okay, here's your next shortcut for the day. We never put frequency lists in for PreCalc, not for a long time now. We're not going to use them. But when I had you guys pull up Y1, and this is a step that some of you are skipping, and you can no longer skip. We're about to get the world's ugliest functions, so you have to store it into Y1. When you go to your test, some of you are like plugging into the rounded function, and you're getting a different answer than the answer key. So from henceforth, you're going to be counted wrong if you're not doing it this way. Okay? So I showed you guys to pull up the Y1 by going varies over to Y varies function. Took us like 3 menu keystrokes to get there. Well, there's a quick key. Remember how I kept griping and I was like, oh man, they need to put this on the keypad. It's so annoying. Well, then Hoffbauer was like, I think they did. So there's what are called quick keys. Have you ever noticed above your top keys there's some green like F1, F2, F3, F4? F4, so if you go alpha trace, everyone just hit those keys for me, alpha trace. Those are your quick keys. And look, it pulled up Y1 right away. So that's a shortcut for me to pull up Y1. A lot easier to get to than the nested like 3 menus in thing. So now it's going to store into Y1, which is what I want. The equation is the quadratic equation, and they're giving you the coefficients for A, B, and C. So what I would like you guys to do is write down your equation. On your paper, there's a blank for your regression equation. And then because of the nature of the function, the correlation coefficient, they're only providing you R squared, but it works the same way as R. 0.99, 99%, pretty good. We'll see how good it is in a minute. So you should be writing down your equation in the blank on your notes. Let's see, where are we at here? And it says around the thousands, so 3 decimal points, please. So negative 0.409, what are we at, x squared? plus 2.762x plus 16.267. And then the correlation coefficient, about 0.993 when you round. So remember how I stored it? That was smart. Because what I just wrote down on my paper, number 1, irritating to type. Number 2, if I were to type that in my calculator's home screen, it's actually not correct because you guys rounded. You truncated. So what we're going to do, I'm going to show you 2 ways where you can evaluate your function. They want to know what the flow rate is at about 10.5 hours. So somehow you need to plug in 10.5. The only thing that would be wrong today is if you literally plug in 10.5 into the home screen, into that function. So you guys don't have your function. You're just going to have to watch me for a minute. One way you can do that is you can change your table. So go to second table set or second window. You can change your table to ask for the independent variable. And what that does is when you go to your table, you can type in manually like any x value you want. It could be as weird as you want. It's not going to autofill because autofill counts by integers usually, and 10.5 won't be hit. Okay, but that's actually not my favorite way to do it because I hate when I mess with my table because I hate it in auto mode or in independent mode. So if you go to your graph, which you don't have anything, so just watch my graph. Now it's graphing the scatter plot with the curve itself, which, I don't know, pretty good fit, right? Looks pretty close. If you hit the trace key, that pulls up your cursor. But remember, guys, there's 2 functions here. The scatter plot is a function, and then the curve itself is another function. And when I hit trace, it automatically goes to my scatter plot. So you might be wondering, well, that's great. How do I get off of the scatter plot? How do I get to the other function? You just hit the up arrow. And it'll pop up to the next function that's graphing, which in our case is the curve. So now that it's on the curve, if you type 10.5 and hit enter, that's another way for your function to be evaluated. Rather than messing with your table, I kind of prefer that method, but it's up to you guys. So jot that number down on your paper. It's, if we round, let's say 0.17. But now we're a little tricky because the labels on the chart don't really match the labels on the problem. So the math comes out to 0.17. But remember on your chart, where's my arrow? Back here. It was hundreds of liters per hour. So I have to take that value of 0.17 and I have to multiply it by 100 if I just want to look at liters per hour. So yeah, 17 liters per hour is how much oil is leaking into the ocean. That seems like a lot.
Is that actually true?
I don't know. Maybe. The rookie numbers, I don't know. There's a good chance someone kind of fudged these numbers, but usually when they're in a math textbook, they like have to actually research and give you real problems. The stuff I make up is just garbage. Clearly. I believe we had a problem about moose, which probably wasn't true at all. I don't know. I'm not going to research this stuff, guys. I don't have time for that business. Okay, so there's a follow-up question here. It says, well, what if you want your y value to be 10? Again, there's a couple of ways where we could figure this out, but we want to utilize our technology because we want the best answer possible. So the easiest way to answer this question when they want you to predict an x value and they give you a y is if you go to y2 and you create a secondary function. This is a way of, quote, plugging in y equals 10. And then you're going to get 3 curves now, the scatter plot, the curve itself, and then this new one. And if you could find this intersection point, that's the answer to your question. So second trace, we choose intersect. This is everyone's favorite because you just go enter, 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 and then boom. The answer is about 8.5. So at about 8.5 hours, you're going to be at that flow rate. All right. So now would be a good time in your notes to make sure that your keystrokes are written down. I know you guys didn't do a lot of those. Let's see, 8.5. So some things that I would expect you guys to be writing down in your notes would be, where did you go to get all these things, all right? So you're entering your lists by going to Stat, over to Edit, or down to Edit, I suppose. You're just choosing it. And then your Stat Plot is where you go for second y equals. And then I would also make a little note about doing zoom 9, which is the zoom stat. That's going to auto-adjust your window for these scatter plots. That's the easiest way to get a decent looking window, but you can always manually adjust them. when we asked you to specifically pull up the quadratic regression, that was from going to the stat menu again, but this time going over to calc. And then you scroll down, I think it was choice A, wasn't it? Quadratic regression was A. I don't know. No, it's not. It's not A at all. What is it? Power regression is A. Where's quadratic regression? Can you guys hit stat over to calc? Tell me what number it is.
Is it 5?
Is it number 5? Okay. I don't know. Okay. And then from there, you can play with the calculator a little bit. All right, so now we're finally going to do one together. So I'm going to pause the video. Everybody get your data entered. You can enter them wherever you want. I'm just letting you know that my data is in list 3 and list 4 because it's already there and I'm not going to delete it. So stat, edit. You guys are entering your data wherever you felt was necessary. Mine is in list 3 and list 4. So the next thing I want us to do together is I want us to look at the scatter plot together. So once you have your data entered, go adjust your scatter plot by going to second y equals and make sure you're graphing the right data in the right spot with the right kind of graph. So like right now, I'm not going to graph the right thing. So remember, I put my data in list 3 and list 4, so I need to fix that. You go up to the name and then hit insert, which is second delete, and then you name it by doing like second 1, second 2. Now, because I have new data, I have totally different window net needs from the previous problem. I need to hit zoom stat again.
How do you change the list?
Are you in second y equals right now? Yeah. Okay. So go to where it is and overtype it with whatever list you want. So it's like second 1, second 2, second 3, second 4. Okay. Is that what yours looks like? Oh, lovely. So not linear. I think it tells you what they want you to use. I think they want you to use what's called the power regression. So it'll be that way on the test. Like we'll just flat out tell you which one to use. So according to whoever was doing this problem first, and they're right, this is the best fit for what's called a power regression. A power regression would be like a really boring monomial function where it's got a coefficient and then like x to some power. But the power is going to be funky because it's real life and it's gross. All right, so go to stat. Once you have your data all entered, everything looks good. This time go over to calculate and then scroll until you see power regression. This is the one that's down at A. Okay, so remember, you got to figure out where your data was. Mine's not here, so I need to change this to list 3 and list 4. And then I'm wondering if anyone is paying attention to my shortcut. Do you remember how we find the regression equation store y1 quick key? I heard alpha trace. Boom, there he is. Nice. Much easier to get to. Thanks, half power. Alright, and then calculate. Moment of truth. If you don't get these numbers, one of us has messed up our typing. And it's you, because I totally know this is the right answer. You didn't get any R's. Do you know why? Your diagnostics were not turned on. Go to mode. And turn them on. Alright, so this time, and man, that's a good fit, guys. 0.99999. Okay, so we'll take that. That's a really decent fit. This power function always messes with kids because they put the numbers in the wrong spot. You're going to plug in something for the coefficient, and then it's times x to some power. This is the gross part, okay? So this is your coefficient, 367.3, whatever they want you to round to. And then your power is like 1.5. Ah, yes, the old polynomial of degree 1.5. Yes. All right, so these are real life questions. Do not come out pretty. This question, by the way, is about celestial bodies orbiting the sun. And the further away you are from the sun, the longer it takes for the orbit to happen. Which, like, makes sense, I guess, because we all kind of learned about that when you were a little kid because of science, you know. But there's the mathematical application to it. And, like, having to calculate the speed of your orbit seems pretty necessary when it comes to science. I mean, I'm not in space, but someone might want to know about this. All right, so I forgot what it was. 300 and... Thank you. Yeah, 0.323 times x to the... And then it's like 1.5 with a bunch of zeros after it, so I'll just put 1.501. That's just me jotting down for my teacher like, yes, I totally found numbers. The correlation coefficient was not the r squared this time, just the r, and it was nice. It was like 0.9999 when you round. It was like decent. So there's no follow-up questions on this one, but I'm going to make one up anyways. So what if you had a moon or something that was, how about 1.25 AUs away? Can you guys go figure this out for me? And there's a couple of ways where you can answer this. But there's one way that will be really, really wrong. What I don't want to see you guys do is plug in 1.25 into this truncated function. That would be a no-no. So someone give me another way to figure out how to plug in a 1.25 and get the most effective answer I can. Throw it into your table. That would work. So my table currently is set up in ask mode because it was from the last problem. Oops, get out of there, ink. And remember how you guys stored your function? If you go to y equals, you'll see like the whole function is there, like a lot of digits, way more than we rounded off to. So going to your table, what was it, 1.25? This is a great way to do the question. Hit enter, it'll pop out your answer. Boom, 513.42-ish. If you want more digits, you can highlight it, and you can get more digits, because it truncates, obviously, for how many characters it allows. If you guys were on your graph, and you wanted to trace, the first time you hit trace, you're stuck on a scatter plot. Can you remind me how I get to the curve? How do I hop off the scatter plot and hop onto the curve? Hit the up button, yep. Now you're on the curve, and then you could have typed a 1.25. That's another way of directly plugging in a 1.25. But first you have to type. There we go. So you're going to get the same answer. The only thing you can do wrong here, guys, is to plug into the truncated function, because from henceforth in PreCalc, if you do that, you're going to get them wrong. Don't do it. All right, the next question. More data. All right, pause the video. I'm going to pause the video. Everyone get your data typed in. If you're curious where my data is, it's already there. It's in list 5 and list 6, but you can type your data wherever you want. So hopefully you're careful typers. One thing I need to do is I like to clear out the old function. It technically overtypes it, but I always get nervous. Remember, my data is in a weird spot, so I have to adjust my scatter plot to plot list 5 and 6. If yours is somewhere else, make sure you adjust yours. And then it does say in the problem, this one's about farm energy, food energy from a farm, input versus output. So it does say to use a cubic regression. So first thing I'd like to do, I got the data entered. I'd like to look at the scatter plot. Not that I don't believe the person who told me to use cubic, but this would tell me if I have something weird typed in. Like if it doesn't look cubic, then I know something's weird. So adjust your window by hitting zoom stat. And I don't know if you guys can recognize that as a cubic function, but it looks pretty decent. Some kids argue like kind of looks more like a cube root function, but it's okay. We'll talk about it in a minute. You broke it. Well, here's how we're going to know if we're good or not, because when we go to calc, and this time you got to choose cubic regression, so number 6. Make sure you put your data from the right spot. Mine's not right. It's 5, list 6. There's no frequency list, but I would like you to store. Give me the shortcut for this again, guys. Alpha trace, good. Such a nice shortcut. See, TI is a very nice company. If we whine enough about something, they give us a shortcut. Okay, so there they are. And a lot of kids are a little short-sighted on this question, and they start writing down their coefficients. So the first thing I see from kids that's a mistake is they write down y equals negative 3.87 x to the third power. Is that first coefficient negative 3.87? It's times 10 to the negative 8th power. There's scientific notation right here, guys. This says times 10 to the negative 8th power. That means you take your decimal point and you move it 8 spaces that way. Guys, your coefficient is negative 0.0000000. Let's just call it 39, because at this point, it's pretty stinking close to 0. As long as you write that down, it's okay. The kid who doesn't write any part of that down is the one who's going to get in trouble, huh? And then the next one is also in scientific notation. I believe it was 1, 2, 3, 4th, negative 4th power maybe. So moving it over, you get 0.00015 x squared. And then the next two coefficients are decent. Oops, next one's a negative though. So minus 0.136. And then plus 167. Well, that is just lovely. You fixed it? You have a data point entered wrong? That's always what my problem is. Oh, that'll do. Alright, so that's a lovely equation. The good news is you stored it, so you don't have to write that anymore. But I would like you to figure out what happens when you have an energy input of 800 calories. So this is an X value. So using whatever method you want, whether it's your table in ask mode or whether it's your graph, I need you to figure out how much calorie output we're working with. Your table's probably already set up in ask mode, so that's pretty easy. If you want to play with the function trace option, go ahead and try that one. Just make sure you're off the scatter plot when you do it. And I think you can get around 136.45 calories. What? Are you doing the table or are you doing the trace on the... You got off the scatter plot, right? Did anybody get my 136.45? No. Do you know why? Because I did the thing you're not supposed to do. I plugged it into this truncated one, I bet. Okay, Adam, what's the real answer? 131.8454. Can I just write that? Anybody get that? Just Adam? Wait, is there no confirmation? Okay, well, you know what? Children, I'm getting impatient. Haha, here we go. Graph. Let me hop off the graph for a minute. Oops, trace. Now I'm going to hop off the graph. And what was it, 800? I got that. Is your data still weird? You have something typed in funny. Yeah. Okay. I guess I didn't do that thing I wasn't supposed to do. Never mind. What happened to your plot? Did you ever hit zoom stat? If you never zoom stat to readjust the window, you might not be seeing your plot anymore. Or if you guys put your data in a different list than your previous problem and you never adjusted that part of your stat plot, that would be the other issue. Yeah. But the moral of the story is, guys, definitely store your equation. Definitely use your stored equation to evaluate your function. If you use your non-stored equation, your truncated version, you're going to get it wrong. The functions get weirder and weirder as we go through PreCalc, yes.
Do you use like a trace value?
You can, or you can just do trace and it pulls up the cursor. And then you can use the up arrow to hop off of the scatter plot and onto the curve. You have to use the up arrow. And then manually type 800. And then hit enter. Okay. Do these keys exactly. Ready? Hit graph. Like get out of your graph and go back into your graph. Okay, hit trace. Press up arrow one time. Type 800. Enter. Okay. I'm going to stop the video. Do your homework.